It is a compound beam. A compound beam is a beam that is really two pieces that have been attached together and connected by a hinge or a pin. Well, if you take an integral, so in other words, you want your calculator to do the integration for you. Weenie. True. But still, that's pretty much a weenie way of doing it. But yes, I'll take it. Because most of you can't do math anyway. Bullshit. So, compound beam means there's some sort of pin that's connecting them. So right here, there's the pin. So what this is really saying is I have two pieces. I have a piece AB and a piece, let's call it BC. Now I brought them together and pinned them together. Normally, a beam is one solid piece. This is different. This is a compound beam. So what I can do is I can unpin them. Let's call this C up here. I can unpin them and break them into two pieces. And that's what I'm going to do. But before I do that, I'm going to, a single force resultant is 3 times 100, which is 300. This is at 1.5 feet from B. So I've taken this rectangular distribution and reduced it down to a single force at a known location. I'm doing chapter 4, section 9. Next, I have this guy right here, single force result is equal to integral A to B, W of x dx. This would be integral from 0 to 4 of minus 3x squared plus 2x plus 40 dx. This is equal to minus 3x to the third over 3 plus 2x squared over 2 plus 40 times x, evaluate from 0 to 4. If I do evaluate, I'll get 112. Now I gotta place it someplace. X is equal to integral A to B, W of x times x dx over single force result. So this is integral 0 to 4 of minus 3x to the third plus 2x squared plus 40x dx. We're going to divide that by 112. This becomes minus 3x to the fourth over 4 plus 2x to the third over 3 plus 40x squared over 2. Evaluate from 0 to 4, divide by 112. You do the math there, x is equal to 1.524 feet. Now I'm going to break this up into two pieces. Piece 1 and piece 2. So, free body diagram, AB, free body diagram, BC. AB, I will have this. AY, AX, moment A. That's from the fixed point. That's from here. On a single force, 112 acting 1.524 feet. I cut through here, so I gotta show this cable tension. And there's a BX, there's a BY from the pin in the middle of the beam. Free body diagram BC says I've got this cable tension T. I got 300, 1.5 feet here, 1.5 feet there. I should have a BX, BY, bindings third law equal and opposite. There's my free body diagram. It's two pieces because I had a compound beam. If it was a regular beam, then I have one piece. There is no two pieces. And this is a compound beam, which means I have a pin in the middle of it. I can break it up into two pieces. Where do you want me to start writing equations is the question. AB or BC? Perfect. What should I do first? Moment at? B. Perfect. Some moments about B, positive counterclockwise. T times 2 minus 300 times 1.5 equals 0. T is equal to 225. Knowing that, I will take that over to this free body diagram and put 225 there. Notice I'm using a different color. To me, that's telling me, hey, that 225 did not come from A, B, came from someplace else. Once I have the T of 225, some forces in the X equals 0, positive to the right. Bx minus T equals 0, Bx equals T, which is 225. Some forces in the Y equals 0, positive up. By minus 300 equals 0, By equals 300. What? Is T not horizontal here? And if these two got a balance. Yes, but it's the same cable. So on this side it's vertical, on this side it's horizontal. So I can carry these over. So I carry those over to the other beam, and now I only have three unknowns, AX, AY, and moment A. Some moments of A equals 0, counterclockwise positive. MA, dump it in, it's a moment already. Minus 112 times 1.524 plus 225 times 4 minus 300 times 5 equals 0. Moment A comes out 770.68. Some forces in the X equals 0, positive to the right. AX minus BX equals 0, or AX equals BX, but BX is 225. Some forces in the Y equals 0, positive up. AY minus 112 plus 225 minus 300 equals 0. AY is 187. And it is upwards. It is to the right. I got positive numbers all the way through. So now you know how to deal with the compound beam. Let me see this. You have your testimony. Notice I have GH, a compound beam. So instead of just giving you a frame with a load at G, I put a beam with a roller. So if you find that roller be up on the beam, it's got to be downward on the frame. This is really a nice problem. It's got the distributed loads, all three types. It's got a compound beam. It's got pulleys. It's got the frame. It's got a 2-force member here, 2-force member there. It's got everything that we talked about. So this is something you need to be able to handle on the test.